Universal Time.
I am in radio contact.
Okay, so today we're doing a follow-up video to the L7805CV counterfeit video that came out on the channel about a week ago. So one of the people in the comments said that my testing method was flawed because I believe it was that I had too much source voltage from the DC power supply. And as a result, the regulator was dissipating too much heat over that. So today we're going to try to address his concerns, and hopefully I can do everything in one take so no one screams that I did a setup off camera or something like that. Okay, so we're going to start. So this is the same batch of 100, what's left of it. So I'm going to pick a regulator out of here at random. Okay, so as you can see, it's still a L7805CV, and also notice the location codes and the date codes. So if you look at some forum posts online, people have these same markings on the ones that they've determined are counterfeit. Okay, so I'm now going to try to keep it in frame. I'm going to set it on the meter so I can get my hand free. And we still have our test jig from the last video set up. So what I'm going to do now, stretch my leads a little bit so they fit into my test jig, like so. Move over here. Get her plugged in. Oh, okay. So I'm gonna screw that down. I'll adjust the frame a little bit. Okay. I don't want anyone saying he's cheating by doing it such and such a way. And yes, this is just some random metal chassis I have that I'm using as a heat sink. But for today's purposes, it works just fine. And I do have a temperature probe, so we'll try to stick that on there and measure that best we could. I think I'm gonna bring up my screw. Try to get it between the, yeah, you know what, that's fine. Try not to put too much pressure on my sensor because I don't want to crush it. Oh, okay, so the yellow clip lead here is going off to the Fluke 87 on the left. This white lead is the Fluke 52 temperature sensor. I'll now introduce the black ground lead. Okay, frame it up a little bit. Okay, so our new suspected L7805CV counterfeit is installed in our test jig. Currently, we are reading 7.00 volts on the benchtop power supply. No load so far. which is interesting that it, in times past when I've used these different regulators, they've shown like 3 or 4 milliamps on the bench. Why, you ask, 7 volts on the bench power supply? That is because the datasheet states that the minimum voltage input shall be 2 volts above what the output of the regulator is. So in this case, it's a 7805. For 5 volts out, we have 7 volt supply on the bench supply. Okay, so coming back down to the jig. Scooting back over. Okay, currently I have no load switched in. Bench supply shows absolutely no load. Thermometer running 65.4. We are already at 4.97, not exactly 5. Switching in load. We are putting in the 250 milliamp load. Bench supply now shows 0.246 amps for 1.7 watts. And we've dipped down to 4.92, starting to rise temperature on the meter. Just so you know I'm not lying, here is our bench supply. 2.44 or so, still 7.0, 1.7 watts. Slow temperature rise on the meter. To the touch, I don't feel a thing. Okay, switching in the 500 milliamps worth of load. Oh, and also this time I don't have a fan running, which was giving me about 170 milliamps on its own in the last episode. Okay, with our 500 milliamps worth of load switched in, we have already gone down to 4.48. Temperature 76.8, still slowly rising. Bench supply now shows 0.44 amperes, 440 milliamps for 3.0 watts. So still temperature rising a little bit, but we're already half a volt down, so that's like 10% out of tolerance. So now I will switch in the 750 milliamps worth of load, the third resistor. Okay, bench supply went to 0.56 amperes, 560 milliamps, 3.9 watts, still shows 7.00. We are down to 3.8 volts, temperature slowly rising, we're at 85 degrees. I can barely feel it on my fingertip. Okay, we'll see how we do with 1 amp worth of load. So with the 1 amps, 4 resistors for 1 amp total of load, we are down to 2.76. Still seeing rise on our thermometer. Interesting, our bench supply hasn't moved. It still shows 0.538 amps and 3.7 watts. But we are getting heat. And I will do 1.25 amps of draw, just so you can see that. 2.1 volts. Power supply still shows 0.531 amperes. Still getting a temperature rise. Okay, I just verified, since this is a variable current power supply, I just verified that my amps coarse and my amps fine dial are turned all the way up. So this supply is, it's designed for 30 volts at 10 amps output. Power supply still shows 7.00 volts, 528 milliamps. And I'll throw my last jumper on there for the 1.5 amps of load, which hopefully I can get that on. So now we're down to 1.77 volts. Benchtop power supply still shows about 520 milliamps. Now 3.6 watts. We are at 100 degrees on the junction. But okay, it barely feels warm to my touch on the plastic case. But apparently under the tab, we are at 100 degrees Fahrenheit. For you Celsius lovers, that is 37.7, 37.8 degrees Celsius. Okay, we're now at 100.4. Okay, so benchtop supply still shows 7.00 with 0.52 amps of load for 520 milliamps. Kind of looks like the temperature has stabilized. Our load resistors are a bit warm to my finger. So, yeah. Okay, just for amusement purposes, I've brought the benchtop power supply up to 9 volts of output just to see if that changed our readings at all. And it kind of looks like that gave us more heat to dissipate, so we jumped about 10 degrees after I did that. And we're slowly going more down in voltage. I'll pull load off. Okay, so we're back at the 250 milliamps of load. Our temperature is going down. .494, which is a little bit off from when we started, but that's fine. Benchtop supply is still dialed in at 9 volts. So I think for this next test, I'm going to drop down my bench supply voltage and then see where we start to see a change on our output meter, so we know what our minimum supply voltage into the regulator needs to be for it to give us the 5 output. Coming down now, we are at 6.94. Okay, 6.5. All right. Give me a second here. Okay, so I'm going to dial this with the V-Fine control. So there is the 7.0 that we started our test with. So I'm going to raise it up to 7.5. So our 8.0, our output isn't changing. Okay. So coming down, 7.5. 7.0. Okay, so 6.90, we're starting to see change. So that's, all right, so back to 7.00, 6.95, 6.90, I get movement out of the meter. 6.85, more movement. So it looks like 6.9, so 1.95 volts is going to be like the over the target voltage. So very close to the 2.0 volts that the datasheet states. So here is 6.8, 6.75, 6.65, and I'm out of adjustment, so that is 6.64. So, like I said, very close to the 2.0 volts that the datasheet calls for. And we are back to a reasonable temperature of 77.4 degrees under 250 milliamps worth of load. I have dialed the power supply back to 7.0 volts on the dot, down to 4.92 for some reason instead of the 4.95, but that's fine, we'll take it. And just because it's the end of the test, I'll put another load in. So we're still the half a volt down with 500 milliamps of load. So now I'll dial up the benchtop power supply to see if this is affected at all. Okay, so it is. So at 7.5 volts, I came up half a volt. So there's 7.57, 7.56. All right, I'll dial it in and find 8.0. All right, 8.01, good enough. Okay, so at 8.0, all right, benchtop supply settled to 8.00. So at 8.00 of voltage input, I'm getting 4.9 volts out at 500 milliamps of load. And our bench supply is showing 475 milliamps of draw. Okay, got a little bit of a temperature rise. But let's see how so we're 3 volts above what the output is, which according to the data sheet, the minimum is 2. 500 milliamps of load, let's see what 750 milliamps worth of load does. Okay, so with that 750 milliamps worth of draw on the output, or I'm sorry, 750 milliamps worth of load on the output, with 8.0 volts in, we show 3.74 output. Bench supply is showing 540 milliamps of draw. Temperature is rising, but still fairly cool. So I'll dial up the bench supply a little bit to see if we can get more voltage out of the regulator. So at this point, as I'm going up on the bench supply, I'm actually losing voltage. So here's at 9 volts input, so we're 3.6. So I'll start dialing it back down to see if we can find a sweet spot. So below 8, 7.5. So it looks like I get the most output of the regulator at 7.7 volts with it drawing the 750 milliamps of theoretical load, but the bench supply is only showing 0.543 amperes. Okay, so hopefully that addresses any concerns that my testing method was flawed with these regulators.